Yeah, hi guys, good evening.
Good evening.
Yes. Just a minute. Okay. Yeah. Okay. We'll start the class. So last class we discussed about the ADCs, right? Yes, we saw what is an ADC and how to get an analog value and convert it into digital. So that we saw for both hardware as well as the work simulator. Okay. So today we will see the timers. So one of the important topic in a device driver or in any hardware, if you take timers are very important. Okay, because all these delays or any task which is running that will be based on the timers only. Okay, so you need to understand this timer concepts clearly. So in order to work with any driver development for any boards, any hardware board, as well as for the bare metal programming also, you need to work on with this timers more. Okay. Just a minute. Okay, I'll share my screen. So if I go to this user, no. Okay, so yeah, this is my data sheet for STM 32F334. Okay, so this we already downloaded, right? Here you can see my board is having something like a 12 different timers. Okay, so I can able to use up to 12 different timers. In that each and every timer is having a different purposes and all these things. So I have one 32-bit. Okay, this is an high resolution timer. Okay, so I have a 16-bit counters for that high resolution timers. Okay, and I have one 32-bit timer and one 16-bit timer with up to 4 input capture and output capture and PW. Okay, so I can able to use one 32-bit timer or one 16-bit timer for an input capture, output capture or PW. Okay, and I have one 16-bit 6-channel timer. Okay, there I can able to use up to 6 PWMs different signals. Okay, this can be used for an dead time generation as well as an emergency stop, something like that. Okay, and I have one 16-bit timer with two input capture or output capture and one PWM signal. Okay, and dead time generation, emergency stop. So I have two different 16-bit timers and two watchdog timer and one system tick timer. This we already seen in that sys. Okay, that's RCC. We are just making the system tick timer, right? And we have up to two 16-bit basic timers that is used to drive for this DAC. Okay, so in total, I'm having something like an so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 2, 3, 4, 5, 6, 7. This is 8, this is 9, this is 10, 1 plus 1. Okay, I have one 13-bit and one 16-bit. So this is 1 to 1 plus 1, and this is 1. Okay, so I have total 12 times. Okay, so I can able to use any timer. I just need to configure this timer, and I can able to use it for the general purposes, or I can able to use it for the PWM generations, or I can able to use it for input capture, output capture, and all these things. Okay, so as for the timer, we need to know some keywords, or I will say some parameter values. Okay, so that we need to know what are these things and all. Okay, first one we need to know about is an prescaler. Okay, so prescaler we already discussed, right, in our previous classes itself. What is prescaler? What is prescaler? Any idea?
Sir, prescaler is
Rounding the frequency.
re- reduce
Mm-hmm.
the counter
Reduce the
reduce the counter bit, sir. Divide the counter value.
divide the counter value. Okay. Okay. Any other definitions?
TS is a counter, sir. That is, it will give a count on to up to
Yeah, before clock frequency,
TS7.
we can use it. That is prescaler.
Before clock signal, you need to use.
Yes,
Okay, what this prescaler do?
it will uh, divide actually, precise the timer actually, I guess.
It will. I didn't get
Divide
you.
the input clock frequency, I
Okay,
guess.
okay. Yes. Okay. So before going to this, we will see one by one. Okay, what is timer in general? What is meant by timer?
Some delay or counting some.
Delay or counting. Okay. Mm, let's say I'm giving something like an 50 milliseconds of delay. How will you calculate this 50 milliseconds? What is meant by this 50 milliseconds?
Like
50 division of 1 milliseconds.
50 divisions of 1 milliseconds. Okay. Okay, good. So it is a 50 divisions of 1 milliseconds. And why are you dividing it with milliseconds? Why can't it with a microsecond? Yeah, that is correct. So 50 milliseconds is a 50 division of a 1 milliseconds. Okay. Why it is?
frequency range 1 by T.
Okay. So this 50 divisions of this 1 milliseconds are okay. In general, what is meant by timer is nothing but it is an a sequential count. Okay, that is what a timer is. So it is an peripheral device that can count the clock pulse. Okay, so we have a clock pulse from our oscillator, right? So what will this timer do is this timer will calculate the clock pulses. Okay, let's say we are having an 8 megahertz of clock pulse. Okay, so clock frequency equal to 8 megahertz. What is the time period for a single pulse? Or just tell how to calculate the time period for a single pulse?
1/8
Yeah, so this is F equal
micro.
to, yeah, F is equal to 1 by T. So that is 1 divided by 8 into 10 to the power of mega means how much mega?
6.
Is it 6 or 9?
No. I think 6 only.
Okay.
6.
Okay, we got it with that. Okay, so it is a 6 only, right? So we have a kilo 3 and mega 6. Okay, so this is actually 1 by, let's say, what is 1 by 8? It will be something like 0. What is 1 by
0.1 something it will come.
exact value. So this is 1 divided by 8. I'm getting 0.125. Okay. So this is 0.125. Okay. So this 10 to the power minus 6 will happen, right? That is nothing but micro. So it is in microseconds. Okay. So if you just make this in a number, I'll get something like an 125 nanoseconds. So a single clock pulse for this 8 megahertz is a single clock pulse is on 125 nanoseconds, or it is 0.125 microseconds.
Actually, T equal to 1 by F, I think.
Yeah. So this is very considered. Okay, sorry. This is T.
Yeah.
I'm just calculating the T. Okay, T is equal to 1 by F, and this is nanoseconds. Okay, so a single clock pulse is actually 125 nanoseconds. Now, if we divide this with something like 50 milliseconds, okay, so 50 milliseconds divided by 125 nanoseconds. So you'll get some number, right? Just assume some number. Okay, you'll get some number. This number will be calculated by your timer. Okay, so if you give this as your number and that much amount of time, your timer will count and it will generate this delay. Okay, it will simply count the clock pulses. For example, let's assume what is 125? Okay, let's assume it is something like 1,000. Okay,
0.4 this value.
0.4.
0.4
This will be 9. I think 400 will come. 4,000 will come. No, it's 3 zeros, right?
microsecond. 0.4 microsecond.
How microsecond?
No.
So this will go, right? It is 10 to the power of 9.
My plus 9 and 10
This is
power
10 to the power of minus
3.
6. No, you'll get 10 to the power of plus
3.
Yeah.
Minus 3, sir. Minus 3.
No,
10
plus 3.
power 3.
10 power 3 will come. Right?
No, 10 power 6 will come, I guess. Because micro minus 3.
This is millisecond.
Sorry, millisecond is
okay. So this is 10 to the power of 6. Okay, so you'll get 4, 1, 2, 3, 4, 5 zeros. So if I give the value of 40,000, okay, it will just calculate the clock pulse for 40,000 times. Once it reaches 40,000, it will again reset to 0. And again, it will start counting from 0 to 40,000. Again, it will come back to 0. Okay. So what is meant by this 40,000? This 40,000 clock pulse of 125 nanosecond is nothing but 50 milliseconds of delay. Okay. So this is how your timer will work. Your timer will calculate or timer will count the clock pulses. Okay. So it is nothing but it is a counter. Let's assume this is my 0. Okay. For each and every clock pulses, your timer will count. So this clock pulse worth 125 nanoseconds. Depends on your clock frequency. Okay. So this will go up to 0, 1, 2, 3, 4, 5 up to 40,000. Okay. So once it reaches 40,000, it will again come back to 0 and again it will start from the 0 to 40,000. Okay. From this to this, the time period will be 50 milliseconds. Okay, so this is how your timer will work. Your timer is simply going to calculate the clock pulses. That's it. Always remember that. It is not going to do any other thing. It is just going to count the clock pulse. Okay. Now, by calculating this clock pulse, what it will do is it will do some multiple jobs. Okay. First one, we can actually able to generate the delay, time-based delay, as like you are giving this HAL underscore delay and all these things, right? So this is a time-based delay that can be able to generate by using this timer. Okay. Second thing, we can actually able to generate the PWM signal. Okay. So third one, we can actually able to use something like an input capture or output capture. Okay. So this is actually used to calculate the frequency of a pulse. So if we get any input frequency, I mean input pulse, we can actually able to calculate the frequency of that. Okay. So that is frequency. Okay. So frequency of your pulses. Okay. So that is the thing. Next we can able to time-based delay, PWM signal, input output capture. Okay. Then we can able to use for the interrupts, or let's say a periodic interrupt. Let's assume your interrupt has to be enabled for every 10 milliseconds. Okay, that you can able to use this timer for generating or triggering this interrupt for the periodic time. Okay, so these are the use cases of the timers. Okay, so by simply calculating or simply counting the by simply counting the pulses, it can actually able to perform all these operations. Okay, so depends upon the board. This timer will be classified into multiple things. Okay, so we have something like an so far I'm writing this for an STM32F334 board. Okay, so depends upon your this classification may get it might be same. Okay, but the timers will be different. Okay, you can refer this data sheet for the timer for each and everything. First one is an advanced control timer. Okay, so for our STM334, it is timer number 1. Okay, this is your advanced control timer. Okay, and next we have a general purpose timer. Okay, so our general purpose timers are we have timer 2, timer 3, then we have timer 6 will come here, 7 will come here. Okay, we have timer 16, we have timer 70. Okay, so these are your general purpose timers. Okay, and next one we have a basic timer. Basic timers, that is we have timer 6 and timer 7. Okay, and the last one is we have high resolution timer. Okay, this is the name of the timer itself and HRTAM. Okay, that is an high resolution timer. Okay, so these are the timers available in our STM32F334 board. Okay, so we are just going to use this timers for the multiple purposes and all these things. The general purpose timers we will be using for mostly the PWM generations. Okay, for an input capture or an output capture. Okay, so this is input capture, output capture, and all these things. So this is actually used for input capture, output capture, and frequency frequency calculation, something like that. We can able to use it. Okay, so this is for an PWM, and this basic timer we can use it for a delay generation, something like that. Okay, and also this advanced timer we can use it for an watchdog timer. Okay, all these things. So this is the high resolution timer. If you want a more resolution for any application, you can use this HRTAM. Okay, so this is what and
Sir,
yeah.
high resolution timer is not there in my board, I guess. I refer to data sheet.
Okay,
I mean, the last one is not there.
HRTAM is not there. Okay,
Mhm.
no issues. Okay, no problem.
Okay.
Yeah. So this HRTAM, what it will do is it has a multiple timer units inside this. Okay, the single HRTAM has an multiple for our board. It is something like an 6 timers present inside this HRTAM. Okay, so this way we can able to use it for something like an fault handling. Okay, if there is any fault occurs in your board. Okay, so that thing and dead time programming. Okay, so for all these purposes we can able to use this high resolution timer. So whichever application requires some microsecond resolution timer, there we can able to use this HRTAM. Okay, now so whenever we use any of this timer, we need to know about two things. Okay, Mhm. First one is prescaler. Then we need to have a frequency, input frequency. Okay. One more thing is just a minute. Is this clear till now? The basics. I'll show you this in the STM cube ID so that you can able to see what is in a clear manner. Okay. I'll simply go to any one of this IUC file. Okay. Let's say I'm going to this timer 6. Okay. We have a counter. Okay. So we'll be having a prescaler, input frequency, and counter period. Okay. So for every timer, you need to know these 3 values. First one, what is a prescaler value you need to set? What is your input clock frequency and your counter period? Okay. So these 3 things we need to calculate. Depends on that, we are going to generate the time period. Okay. Now, input frequency, we already know what is meant by this input frequency. This is your simple clock frequency. Okay, so depends upon each and every board, this clock frequency can vary. Okay, so for our STM F334, it may vary from 8 megahertz to 64 megahertz. Okay, so 64 megahertz for some clock, some timers, and some timers have 72 megahertz. Okay, but mostly we'll be dealing with the 64 megahertz only, right? So we'll be having 8 megahertz to 64 megahertz range of clock frequency. Okay, so that is what an thing is. Okay, now this counter period, or we call that as an timer clock. Okay, this as already said, your timer is nothing but it is an counter, right? It is just going to count the clock pulse. Okay, this can be either an up count, we call this as an up count, or we can actually able to do the down count. Okay, so this counter period can be up count or it can be an down count. Okay, so up count means it will start from 0 to this maximum value, and then again it will come back to 0. It will start from this 0 to maximum value. Down count means it will start with the maximum value and it will reduce it, okay, to 0. So once it reaches 0, it will again go back to this maximum value and again it will come back from this. Okay, so this is what a down count and up count is. Now, for this prescaler, this is one of the most important thing in your timer calculation. Okay, so prescaler is nothing but it divides the input timer frequency. Okay. Now, what is meant by these divides, or why I need to divide this input clock frequency? That is the question. Okay. Now assume you are having a 64 megahertz of clock frequency. This is a fixed value, right? You can't be able to change this value anywhere unless you are changing it in the program. That will change for the entire peripheral devices. For example, if you set it something like an 32 megahertz, the 32 megahertz will be set for your entire peripheral device. Okay, I need only for the timer. Okay, I need an prescaler 32 megahertz for my timer alone. All other peripheral devices can be 64 megahertz. Okay. For that, what I will do is I will just divide this input frequency with some value in the prescaler. Okay. That can be give for the timer clock. Okay. So the timer clock value will be F timer clock, the timer clock frequency. This is a formula. Okay. This is nothing but F APB clock divided by prescaler plus 1. Okay. So if you want to generate or if you want a timer clock, you need to divide that with an APB. APB clock is this is your input frequency clock. Okay. So that is what this APB clock. That value divided by whatever the value you are giving in the prescaler plus 1 you need to give. Okay. Let's assume your input frequency is 64 megahertz. Okay. I need 32 megahertz of clock frequency. What should I do for the prescaler? Simple. What should I do? I have a 61. Okay. Prescaler as 1. So for this 64 megahertz clock frequency, I need to set my prescaler as 1. So that is 1 plus 1. Then I will get an F timer clock will be 32 megahertz. Or if I want an 8 megahertz of clock frequency. Okay. What should I do?
7. Prescaler must be 7.
So prescaler must be 7. Okay. So that I will get an timer frequency as per my calculation. Okay. So why I need to change the timer clock? I can directly take this APB clock, right? Why should I need this timer clock and all these things? Okay. Now we already know timer by definition it is a counter. Okay. Either it can up count or it can down count. It is going to count the clock pulse. Assume you are having a 32 megahertz of clock frequency, or let's say you just change it to 8 megahertz of clock frequency. Okay, you're just dividing it by 8, so you're just having a timer clock equal to 8 megahertz. Okay. Now okay, let's say this is 8 into 10 to the power of 6, or I will just write it as 8, 1, 2, 3, 4, 5, 6. This much amount of value. Okay, now I need 1 second delay. Okay, I need 1 second delay. So what value I should give for this counter in order to get in 1 second delay? Or let us put in the same way like what we did in this first calculation. Okay, this is 8 megahertz, right? That means what is your T? We already
0.12, I mean,
yeah, this is
125 nanosecond.
So it is 125 microsecond or 125 nanoseconds. This is your T. Okay. Now, what value I should multiply this in order to get in 1 second? Just divide it with 1 second. With 125 nanosecond, you will get that value. Correct? Okay. This is nanosecond. So you will get 1 into 10 to the power of 9 divided by 125. What value you will get? Just divide
0.008.
It is 0.008 into 10 to the power of 9, right?
Yes.
Okay.
8 mega, I mean 8 megas kind of.
No, this is actually like this much amount of time you will get. Okay. You need to give this
This mean
counter value, okay, for generating an 1 second delay. Okay. Assume you are having a 16-bit timer. Okay. What is the maximum value you can give in the 16-bit? 2 power 16, which is nothing but 65,536. That is the maximum value you can able to give. Or it can be 0 to 65,535. Okay. Only this much amount of value we can able to give. But I need this much amount of counter time to give for generating an 1 second delay. I can't able to do that, right? Is it clear? Okay. If it is a 16-bit timer, the counter value, the maximum counter value I can able to give is a 65,536. Okay. But for generating a 1 second delay for 8 megahertz frequency, I need this much amount of time has to be given for the counter, but I can't able to do. Is it clear?
okay.
Okay. So now what I will do is I can't able to increase this bit. This is a fixed one. Okay. I can't able to increase that, but where I can able to change it, I can able to change the prescaler value in order to make this reduce the number. Okay. For example, let's say if I give my prescaler value itself as an 8 kilohertz. Okay. So my prescaler equal to 8 kilohertz. And my F AHP clock is 8 megahertz. Okay. What is my F timer clock? It will be 8 megahertz divided by 8 kilohertz. What I will get?
1 kilohertz.
So I will get in 1 kilohertz. So what is my time period? My time period will be 1 milliseconds. Okay. Now, in order to generate an 1 second delay, what is the counter time I can give? The counter time I can give for 1000. If I give 1000, it will generate a 1 second. That is 1000 millisecond, which is 1 second. Correct? See, my single time period is 1
Yes, sir. Yes,
millisecond.
sir.
Okay. I need to multiply it with 1000 in order to generate the 1 second delay. Okay. So my counter time has to be 1000 in order to generate the 1 second delay. Okay. For the same 1 second delay, last time, what is the value I need to give? This much amount of value. Okay. For the same 8 megahertz clock frequency. Here, for the same 8 megahertz clock frequency, now the counter value I can able to give is 1000 only. Okay. So by simply adjusting this prescaler value, I can able to increase or reducing this counter time. Okay. Clear? So that is what called as a prescaler. Prescaler is going to divide your input clock frequency in order to match with the counter time period. Okay. Is it clear? Or do I need to explain it again for anyone? Just tell me if you didn't understand it, because without this, you can't able to write any code. This is very important. Is it clear for everyone? This calculation, what is the use of an prescaler?
One time repeat பண்ணுங்க sir. Please color.
Okay. 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 Prescaler means it will divide the input clock frequency. Divide the clock frequency. That is what a by definition the prescaler is. Okay. So prescaler is going to divide your clock frequency. Now, why it need to divide the clock frequency? That is what the question. Okay. So your APB clock, okay, that is APB frequency clock pulse, it can actually able to generate from 8 to 72 megahertz of clock frequency, or in some board it can generate up to 170 megahertz of clock frequency. Okay, for some discovery boards we can able to generate 170 megahertz of clock frequencies. Okay, that is possible with the APB frequency. Okay, now okay, now if I give something like an 72 megahertz, let's assume my FAPB is an 72 megahertz. Okay, so that means 72 into 10 to the power of 6 hertz. Okay, now by definition we know that timer is, it is going to count each and every pulses. Okay, now in order to calculate the pulse we need to divide it by the time equal to 1 by f. So I just need to divide it by 1 by 72 into 10 to the power of 6, which will be what is 1 by 72? 1 divided by
0.0139.
Okay, so it is 0.0139. 10 to the power of 6 is minus 6, right? That is a microsecond. Okay, or we can say it is in 13.9 nanoseconds. So for a single pulse, that is from your clock frequency, it will just generate the clock pulses, right? Like this. This is what your oscillator will do. Okay. Now this single clock pulse, that is start from this to this, the time period it takes is 13.9 nanoseconds. Okay. Now with this we can't actually able to calculate. For example, I need to generate an 1 second delay. I have an LED. That LED has to on for 1 seconds and off for 1 seconds. Okay, this is what my requirement is. Okay, now I know the time period for a single pulse. Single pulse time period is 13.9 nanoseconds. Okay, now how many clock pulse it requires to get this 1 second? The same thing, you just have to divide it with this one. You will get 7 to 1 2 3 4 5 6. Okay, this much
70.
amount of this much amount of pulse you require to generate an 1 second delay. Okay, for 2 seconds delay you just have to multiply it with 2, something like that. Okay, now can we able to give this much amount of value to, there is something called as a control register? Is no, your control register is actually an 16-bit or a 32-bit, because it depends on the timer, which timer you are using, whether you are using a 16-bit timer or a 32-bit timer. Okay, so if you are using a 60-bit timer, the maximum value you can give for the counter is 65,536. That is the maximum value you can able to give. Okay, now if it is the maximum value, you can't be able to generate the 1 second delay with this, right? In a 16-bit timer, that is impossible by using this value. Okay, now in order to avoid that problem, we are using something called as a prescaler. Now what this prescaler will do, the prescaler is going to divide this clock frequency, whatever the clock frequency you have. Okay, so what is the only solution for this? I need to reduce this frequency, right? If I reduce this frequency, then I can able to fit it inside this 65,536. That is possible. But can I able to replace a single crystal oscillator for only timer, that is not possible. Okay. So now for that same hardware, we can actually able to use something called as a prescaler in a timer that is going to divide this frequency. Okay. So I'll just, how it will do, your timer clock, f timer clock equal to this frequency, that is f APB frequency divided by your prescaler plus 1. Why it is prescaler plus 1 means you can actually able to set this prescaler to 0 also. That is possible. Okay. If you divide it with 0, it is on division by 0, you'll get an infinite clock frequency, right? So in order to avoid that, you are just adding it with 1. That's it. Okay. So if you give the prescaler as 0, you will be just giving f APB by 1. That is the thing. Okay. Now here your frequency is 72 megahertz, right? Okay. You can actually able to set this prescaler as something like, let's say, 72. So this is 65,000, right? Okay. I'll just give it as an 36,000. 36,000. Okay. Now what is a timer clock? What is the frequency?
Zero 0.002.
It is in a mega.
No, yeah. This 72 divided by
Okay. Okay.
3000. Yeah.
Just tell me in the seconds or frequencies.
2 frequency, 2 kilohertz.
So it is a 2 kilohertz. Okay. So your FTC is a 2 kilohertz. Okay. So 2 kilohertz is nothing but it is in 0. This is 500 millisecond, I think so. Sorry, 0.5 milliseconds, I think so. Correct. 1 by 2 is 0.5. Yeah, it is 0.5 milliseconds. If you convert it into a time period. Okay, t is equal to 0.5 millisecond. Now, in order to generate a 1 second delay, what is the counter time I need to give for this time? What is the counter time? I have a 0.5 second. So now this is converted into, instead of 13.99 a second, you are actually converting it into 0.5 milliseconds. Okay. So each and every clock pulse is now 0.5 millisecond generation. Now, if I give something like a 2000 in the counter, that means it can be able to generate the 1 second delay. Okay. So by using this prescaler, we are actually reducing, or we are, in technical term, if I say, we are just slow down the frequency of your clock. Okay. So that is what we are doing with the prescaler. So prescaler is going to divide your input frequency. Why we need to divide it? That is the this calculation. Okay. So by definition, it is going to divide the clock frequency. Simple. But why we need to divide it? We need to achieve this counter value. Okay. So for that, we just need to divide it with the prescaler. Clear, Rajman?
Yes, sir.
Yeah. So others, is it clear? Because we need to
Yes.
set all these values in our STM. Okay, that's what I'm explaining it for this much amount of time. Okay. So this counter, there is another name for this, which is called as an ARR. Okay. So this, what is meant by ARR is, this is an auto reload register. What will happen once it goes to 0 to, let's say, in our case, it is 2000, right? Once it reaches 2000, it will again come back to 0. Okay. Again, it will go to 2000. So it is actually reloading it again and again, right? So we call that as an auto reload register, ARR. Okay. So this one is an auto reload register. Okay. Now we are just going to give the same value for all these things, right? Okay. Now what I'm going to do, I'm just going to create a new project here. STM32 project. First, we will generate the time period. Okay. Then we will see the PWM. No, we will see the bare metal programming for the timer delay generation. And then we will see the PWM. And we will see one more program for PWM to this LED. No, we can able to adjust the brightness by using this PWM. Okay, that we can able to try it if we have a time. Okay, so I'm selecting this STM32F334 board in the new project. So I'm just going to give timer delay in hardware. Okay. Yes, so this is my board. So what I'm going to do, I'm just going to this RCC. This is bypass and this is my crystal ceramic. Okay. Now I'm just going to turn on this inbuilt LED. Okay, so I'm just going to make this as an GPIO output by using a timer. Instead of using an HAL delay, I'm just going to blink this LED with an um, timer delay. Okay, so that we will try. Now, so for timer, I'm just clicking this timer here. Okay, so here I have this much timers. Okay, so this is my high resolution timer. We have a timer 1, 2, 3, 6, 7, 15, 16, 17, all these things. Okay, in that, as I already said, I have this basic timer, general purpose timer, high resolution timer, and advanced control timer, right? Okay, so this timer one is an advanced timer. We have a slave mode, clock source, and all these things. And this timer two again, timer three, these two are your general purpose timers. Okay, and this timer six and timer seven are your basic timers. You can see that modes over here. If I click timer 2 and 3, you'll be getting this modes. If I click timer 1, you'll be having more number of channels. Okay, and if I click timer 15, you will be having only two channels with an internal clock, trigger source, and all these things. Okay, so your timer 16, 17, and this 6, 7, these are your basic timers. Okay, we can actually able to use this timer 6, 7, 16, 17 for your basic timer. So I'm just going to use a timer 6. Since it is a delay generation, I'm just going to use this timer 6 here. Okay, so similarly in your as per your board, you can see which is your general purpose timer, which is your basic timer, and all these things. Okay. Yeah. So I'm just going to give this timer 6. I'm going to activate this. That's it. Okay. Now before this, I need to check what is the clock frequency for my particular board. Okay. So here we are going to use an APB for your timer, right? Okay. So this has to be fine by directly going to this data sheet. Uh, yeah. Okay. You can see some of the timers are connected in APB2 that is having a maximum of 72 megahertz frequency. Okay. And some of your timers like timer 3, timer 6, timer 7, all these timers are connected to APB1, which is having a maximum frequency of 36 megahertz. Okay. So that you need to see in your data sheet, like which timer you are going to use and what is the maximum frequency you can able to give for that particular uh, timer. Okay. All these things you can give. So here my timer number, which timer I given? Timer number 6. Okay. My timer number 6 is actually connected in APB1. So I can able to use up to 36 megahertz of frequency here. Okay. Maximum frequency. Okay. It need not to be always 36 megahertz. Maximum you can able to use 36 megahertz. So that is APB1, right? APB1 timer clock. You can see for APB1 timer clock, I am using 8 megahertz of clock frequency here. I'm just using a system default 8 megahertz of clock frequency. Okay. If you select nuclear board instead of MCU MPU, then you will get 32 megahertz over here, 36 megahertz over here. Okay. So if you want, you can actually change it. Something like, let's say I'll use this PLL for a source. So we have, let's say I'm just going to give it as an 8. Mm, 64, right? So 16 into 4. Okay, 64. Here I'm going to divide it by 2. You can see my APB1 timer clock, I'm just giving in 64 megahertz. Okay, so what is my APB1? It has to be 36 megahertz, right? So I'm just giving it divided by 4. Yeah, you can see. So it is 32 megahertz. So you can change it over here in this clock frequency tab. Okay, depends on what frequency you are getting. You can just change the PLL multiplier, prescaler and all this. Here I'm just dividing it by 4 with this prescaler. Okay, this is I'm just dividing it with 1. That's it. Okay. So all these things you can able to work it over here. If you want an thing, just click refresh, you will get all these things. Okay. Now you can see I'm having an 8 megahertz of clock frequency. Okay. So I need to do the calculation for this 8 megahertz only. Okay. Now inside this timer 6, once I activated it, I'll get a parameters like this. What is the prescaler? Okay, so my prescaler value has to be 16 bits. That is maximum I can able to use as 65,536. And whether I'm going to use an up counter or a down counter, and what is the counter period? Okay, that I need to give. Okay, now I'm going to use the same calculation what I did here. That is, okay, let's say I'm having an 8 megahertz of clock frequency, right? Okay, so I'm just giving an 8,000 for my prescaler. So if I give 8,000 for prescaler, I'll get 1 millisecond time period. So I need to give a counter period as 1,000. Okay, this is the calculation I did. Okay, I'm just going to use the same thing. Okay, so now here it is 8,000 minus 1. Okay, why minus 1? Because there we will be adding plus 1, right? Okay, so either you can put in 7,999 or 8,000 minus 1, whichever is fine for you. Okay, now I'll just do the calculation here once again for you people. My APB frequency is 8 megahertz. Okay, Here the prescaler, I'm just giving it as an 8000 minus 1. So prescaler, I'll give it as an 8000 minus 1. Okay. Now I just need to give this counter period, that is your auto reload register. Okay, that is I need to find this ARR. What is the ARR I need to give? Okay. Now first you need to calculate the timer clock frequency. Okay, that is FTC, timer clock frequency, equal to FAPB divided by prescaler plus 1. Okay, that is 8 into 10 to the power of 6 divided by, this is 8000 minus 1 plus 1, you will get an 8000. Okay. Now what is an FTC? You will be getting 1, this 3, this 3. You will get something like an 1 kilohertz. Correct? This is a frequency only. Is this clear?
Yes, sir.
Others? Okay. So I know this FTC is an 1 kilohertz. I need to convert this into time period. So T equal to 1 by F, that is 1 divided by 1 into 10 to the power of 3. So that will be 10 to the power of minus 3, right? So that is 1 millisecond. So my time period will be 1 millisecond. Okay, for a single pulse. So this single pulse is 1 millisecond. So how many pulse I required for 1 second? I need to blink my LED for 1 second. So how many pulse I need?
1000.
1000 pulse. Okay. So this ARR value has to be 1000. Okay. Is it clear?
Sir, can you explain again that the clock generation?
Which one? This white color.
Clock fault, sorry, configuration. Clock configuration.
Okay. Here. Okay. This clock configuration. Okay. So as we already know, we have an high-speed internal clock, high-speed external clock, and PLL clock. PLL clock is nothing but PLL is an exact opposite of your prescaler. Prescaler is a divider, PLL is a multiplier. Okay. Now you can see I actually taken this HSI, that is my, this is my 8 megahertz of internal clock frequency. Okay. You can see the line. I'm just taking the internal clock frequency and I'm just multiplying it with fit 2. Okay, so here I'm just dividing it with 2. So I'm just getting a 4 and I'm multiplying it with 2. So here my system clock will be 8 megahertz. Okay, so if I change it to PLL, and you can see if I change it to 4, you can see it is 16. If I change it to 6, it will 24. If I change it to something like an 8, it will be 32. Okay, you can actually able to adjust the amount of clock frequency you can able to get by just simply giving this multiplier value. Okay, so this is for PLL clock. If I need to get an internal clock directly, so just give this internal clock. And here, if you want, you can change this frequency value. Okay, for example, let's say I'm just giving this value 64 megahertz for all these peripherals, except my APB1 prescaler, I'm just giving it 2. Here you can see my APB peripheral clock will be 32 megahertz. My timer clock will be 64 megahertz. Okay, and all other things are 64. Now I need to give this prescaler value counter time depends on the 64 megahertz. Okay. So this is how you can able to
Then
change.
input clock frequency is a 64 megahertz.
64 now.
Here. So the
Here.
APP1 timer clocks.
Yes, this one. Now it is
Okay.
changed to 64. Okay, now we need to give this prescaler for the 64.
Okay.
Okay. Yes. So here, as I have calculated, this ARR has to be 1000 in order to generate the 1 second delay, right? So I'm just giving, instead of 65,536, I'm just giving it as 1000. Okay, that's it. So one GPIO, one timer. That's it. Okay, so only this prescaler and counter you just have to calculate for every time. Everything else is same.
Sir, but
Hmm.
this scalar value, it's assumption only, right? We can able to make change also. 8,000 means we can keep us
No, that is not an
66,000 or
assumption.
something.
That is calculation.
No, first time we were having
We
8,000
didn't
also.
assume it. We calculated it. That this prescaler value. Okay, in order
Yeah,
to get this 1 kilohertz, I'm just giving it
Hmm.
as an 8,000. Okay, if it is something like a 64 megahertz, let's say if I give something like an 8,000, I will get 8 kilohertz. Okay, how will you generate an 1 second delay for by using an 8 kilohertz? Is it possible?
Yeah.
Hmm?
Okay, understood.
Yeah. So we just have to do that. If you just divide it with 8, your time period will be 0.125 milliseconds. Correct?
Yeah.
Yeah. Then your ARR has to be 8,000, I think, in order to get this 1 second delay for this 64 8,000. Right? If you just multiply this with 8,000, you will get in 1 second.
Yes.
Correct?
Yeah.
Okay. So it depends on what value you are giving, this ARR will vary. So this is not an assumption. This we need to calculate it.
Okay.
Hmm? Yeah.
So, in that case, whatever the megahertz we are choosing, that is 8 megahertz means we need to take that one minus like that only we will take. Right?
Yeah, we
That
need
is
to.
8 megahertz means we'll take 8 kilohertz as a base color. Like that, if you taken 64 megahertz means 64 kilohertz we can take.
See, this is for 1 second delay. I'm just using it. Okay.
Mm-hmm. Mm-hmm.
Let's assume you need a 500 millisecond delay.
Okay, so depends upon the
Yeah, depends
milliseconds
upon
we
what is
can.
your delay time.
Mm,
You can just give that value.
okay.
Okay. Yeah.
Mm-hmm.
So this is like you can put any number, you'll get some clock frequency. Okay, this is not always fixed. Like for 8 megahertz, you need to give it 8,000. Okay, you can give 4,000 also, or you can give 1,000 also. Okay, depends on what value you are giving. This ARR is going to vary. That's it. If you understand this calculation, then you can put any value for your prescaler and you can calculate the ARR value.
Yeah. That's what I asked. Maybe it's our assumption we can able to do like
Yes.
that. Okay. Yeah. Okay. Understand.
Okay. So now what I will do, I'm just going to use this timer in the interrupt mode. Okay. So for that, I need to go to this NVIC setting and enabling this timer 6 in the interrupt. Okay. So whenever this time period expired, I'm just going to go to this callback function and I will just blink this LED. That's it. Okay. So for that, I'm just giving this as an interrupt. So NVIC setting, I'm just enabling this as an interrupt and then I'm just going to generate this code. Okay, this is generated. I'm just going to close all other projects. Okay. Here you can see and handler for timer 6 is created. Okay. And here timer 6 initialization is also created. Okay. Now, what we need to do is, since it is in the interrupt mode, first we need to start the timer. That's it. Once this timer has been started, it will just do all this counting. Once it reaches 1000, it will just trigger the interrupt. Okay. So since I have given this ARR as 1000, what it will do is it will just start from 0. Okay. It will just calculate or just will just count each and every pulses once it reaches the 1000 value. Okay. Once it reaches 1000 value, it will just call the interrupt, or it will just trigger the interrupt, and it will just reset to 0. Okay. Once again, it will start counting and it will go up to this 1000. Once it's 1000, it will again call the interrupt. Okay. This time period from this 0 to this 0 is your 1 second delay. Okay. Because each and every pulse is your 1 milliseconds. Okay. So this is my 2 millisecond, 3 millisecond, 4 millisecond, up to it will be 1 second delay. Okay. Similarly, this will be again an 1 second delay, something like that. Right. So for that, I need to use this one. Okay. Here user code begin to, I'm just going to give al underscore timer underscore base. Okay. I'm going to start this timer, right? So I'll just give base underscore start. You can see this timer can be start as a normal timer, or it can be start in the interrupt mode, or it can be start in the DMA mode also. Okay, so here I'm just going to use it in the interrupt mode. So I just select this. It is asking which timer I need to start. Okay, so I'm just starting this H timer 6 in the interrupt mode. That's it. Okay, I have started the timer. So now this count will start. Okay, once it reaches interrupt, it is going to trigger the interrupt, and this interrupt will search the callback function. Okay, so that callback function we need to write as like your yesterday for ADC we have given, right? The same thing. Where it is user code begin for. Yeah, here we need to write our callback function. So that is void hal underscore timer underscore periodic elapsed callback. Okay, this we need to do. So just make sure it is correct. If you click this, callback function is not loading. So I need to give this in the interrupt. Okay. So al underscore periodic. It's not a periodic. This is period. Al underscore timer underscore period elapsed callback. Okay. Yes. Okay. Just hold the control button and click it to make sure you are writing it in the correct thing. Okay. So this is what my function. Inside this, I'm just going to give an time handle type def as like your yesterday program, same thing. I'm just going to give an H timer. Okay. So what we did yesterday in the ADC, once it comes to this callback function, we check the instance for ADC1. Correct. Similarly, here we are going to check the instance for H timer, your instance. Okay, if it is double equal to your timer 6, because here I have given timer 6. If you are selecting a different timer, you can use that timer value. Okay, so this is for timer 6. If your instance is timer 6, what I need to do, I'm just going to toggle my GPIO pin, right? So I'm just going to give al underscore GPIO underscore toggle pin of A pin number 5. That's it. Okay, is it clear? This is the same thing like what we did in the ADC yesterday.
So, okay, sir, but what it does, like for 1 second it will on and one
Yeah.
second it will off.
Yes, for each and every
Okay.
second, 1 second, this callback function will be called. Okay, so during that time it will toggle.
Okay.
And we need to actually write one more thing. So just go to this driver STM include. There is something called as an STM32. And just go to this IRC. Yeah. So go to this include folder. In the core include folder, this IT underscore dot h. Here we just need to write one more function. Interrupt request function. STM32 ITH, right? Okay, let's check whether it is working without this. It has to call the function. If it is not manually, I mean, automatically calling, we can manually call it. Okay. Where it is, yeah, this one. I'm just going to connect my board. I built it. There is no error or a warning. I'm just going to connect my board. Right click, debug, STM. Okay. Which yeah. So it is actually working without that callback function. Just a minute. I'll connect to Teams. You can see over here. Okay. So this is 1 second on off. With my inbuilt LED. Clear? So start the timer here. Okay, start the timer here and then give the callback function. Since it is in the interrupt, just give the callback function here. That's it. Just try this and tell me whether you are getting an output. If you are facing anything, just let me know.
So can you show that configurations? the time window. So parameter setting.
Clock configuration or this one?
Yeah, this.
Okay. This is NVIC only, you just need to enable, and parameter setting, you just need to give the prescaler and counter. That's it.
Okay. So can you show that user code 1 and 2 at all?
Which one? User code 2 only, this single line.
Uh, So this HTML6 variable is created internally or
No, it is
we have
internally
it in the
created. This handler.
we need to create or is
No, it is automatically. Once you give this timer 6, okay, and generate the
Okay.
code, this handler will be automatically created.
okay.
So those who are using this WorkV, just generate the same code and same thing for WorkV simulator. Okay, with the basic timer in that C0. Just a minute, I'm taking a call. Yeah, have you finished?
Sir,
Yes.
sir, நியூக்ளியோ C031க்கு clock எவ்வளோ சார் செட் பண்ணணும்? சேம் 32.
ஆக்சுவலி நியூக்ளியோ C031க்கு வந்து அதுல 8
டிஃப்ரெண்ட்டாக
மெகாட்ஸ்
இருக்கும்.
தான் இருக்கும் நினைக்கிறேன்.
80 தான் இருக்கு சார். ஓகே தானா அது?
அது ஓகே தான். நான் இங்க 8 தான் செட் பண்ணியிருக்கேன்.
ஓகே சார். 36க்குள்ள எவ்வளோ வேணா வச்சுக்கலாம்.
என்ன வேணா வச்சுக்கலாம்.
ஓகே சார். டைமர் 6 இல்ல. டைமர் 16 யூஸ் பண்ணிக்கலாம்ல. 16 ஆர் 17.
ஏதோ ஒரு பேசிக் டைமர் எது
ஓகே
வேணா
சார்.
இருக்கலாம். Finished.
This is interrupt-based timer.
Yeah, it's an interrupt based timer.
IT, the start.
Yeah, we are starting this timer in IT.
Yes.
Finished? Have you got output?
Yes, sir.
Okay, others? I thought to finished the bare metal also, but we have only 10 minutes left. Mhm.
Yes, sir, complete.
Okay. Look, I'll just give an intro of the bare metal programming. Okay, so that we'll see tomorrow, but I'll tell you what are the things we need to do. Okay, as like your GPIO bare metal programming, here also we need to see this architecture diagram first. Okay, so here let's say I'm just going to use timer number. Which timer I use? Timer 6, right? Okay, timer 6 I'm going to use here, right? So for that, let's check where is my timer 6. So timer 6 is over here. So this is my timer 6. So I need to enable the APB1. Okay, so that is the first thing. And I need to enable the PFI for this LED blinking. Okay, that is GPIO port A. Okay, that is your AHP. So two things. First one, step number one is, okay, I'll write it in some other. Okay, I'll open this one. Okay, I'll write it here. So step number one, enable AHB or PFI. Okay, so that is port A, GPIO I need to enable first. And second step, I need to enable this APB1. Okay, so this one APB1 bus for APB1. This is for timer 6. Okay. So this is step number 1 and 2. Okay. And third step, I need to make this PFI as an output mode, right? So I need to set the mode for PFI. Okay, so that is as an output. So this we already did. Like the first step we know how to do. Third step we know how to do that. Okay, so that is as like what we did in the first bare metal programming, the same thing. Okay, and in step number 4, we need to set the prescaler value. Okay, and the ARR, that is auto reload register value, and then the counter, the initial counter, whether I need to start from the 0 or I need to start from the maximum value, that is up counter or a down counter, that I need to set. Okay, so this is my step number 4, and step number 5 is what my actual programming is. Okay, so step number 5, this is while of 1. Inside this while of 1, what I need to do, I'm going to check there is something called as a status register. Okay, so since it is in the interrupt mode, what will happen whenever this time period expired, that is once this auto reload timer reaches the time period, it will set a flag. Okay, so that is a status flag. So I'm just checking the status flag. Okay, so if it is set, if the status flag is set, that means this has reaches the maximum value, that is the counter value. For example, in our case we are given 1000 as the count value, right? Once it reaches 1000, this flag will be set. Okay, once it is set, what we need to do, we need to toggle the LED, toggle the PF. Okay, so after this, here the status flag is set, right? So last step, we need to reset the status flag. Okay, these 3 things will actually give inside the while of 1. Okay, so first it will check the status flag. Once it is set, it will go toggle this and it will reset. Again, it will check if it is set, it will toggle and reset. So when this flag will be set, it will set once this reaches an ARR. When this ARR will set once it reaches 1000, that is for each and every 1 second. Okay, we are just going to toggle this PFI. Okay, so this is the bare metal step for the LED blinking. So we just need to follow these 7 steps in order to blink the LED. That's it.
To setting the prescaler ARR further in the register, we need to set.
Yeah, register. So there is an keyword for that. For this prescaler, we have something called as an PSC. And for ARR, we are having something called as an ARR. And for counter, we have something called as an CNT. These are registers.
Okay, so we need to go to timer 6 register.
Yeah, timer
we
6.
Need to set this.
Yeah, that's it.
Okay.
Timer 6 PSC. There we are given something like an 8000 minus 1, right? So same thing we can able to give it over here.
Okay. Status flag also in the timer 6.
Yes, so that is status register. This is SR status register. Timer 6 status register.
Okay, it's a separate register or it is inside the timer 6?
It is inside the timer. If you go over here, we have a basic timer, timer 6 and timer 7 on the left side. Okay, so if I just open this and if I go to the register, you can find the status registers. Yeah, this one. Timer 6 status register. This
Okay,
one.
sir.
Update interrupt flag. If it is 1, then we are just toggling that PFM. That's it.
Okay, sir.
Okay, so this program we will see tomorrow. Okay, so just understand what this one is. So that's what I have given here. So we will see this program as well as we will see PWM. Okay, how to
PWM.
write a PWM. Okay, that also we will see. And PWM bare metal programming, as well as by using this PWM, we can actually able to you know, adjust the brightness of LED, that we can able to do. Okay, that we will see tomorrow. Okay. Yeah.
Sir,
Hmm.
sir, void loopல one error வருது சார். அந்த period elapsed callback அந்த லைன்ல error வருது.
அது ஸ்பெல்லிங் கரெக்டா கொடுத்துறீங்களா செக் பண்ணுங்க. நான் காமிக்கிறேன். இதே ஸ்பெல்லிங் இருக்கணும். ஐ மீன் கேபிட்டல் ஸ்மால் எல்லாமே ஒரே மாதிரி இருக்கும். இது கரெக்டா இருக்கா செக்
ஓகே
பண்ணுங்க.
சார். பீரியாடிக்
பீரியாடிக் இல்ல பீரியட் தான்.
பீரியட் elapsed callback. சேமா தான் இருக்கு. வேற ஏதோ சம்திங் ஏதோ மல்டி ஃபங்க்ஷன் சொல்லிட்டு ஏதோ எரர்.
மல்டி ஃபங்க்ஷன்னா அப்போ ஃபங்க்ஷன் ஆல்ரெடி டிக்ளேர் ஆகிருக்குன்னு அர்த்தம். ஓகே, ஸ்க்ரீன் ஷேர் பண்றீங்களா?
ஓகே சார். மிஸ்டேக் ஆயிடுச்சு. சார் ஷேர் ஆகுதா சார்?
ஸ்க்ரீன் தெரியுது.
ஃபீல்டு இந்த மாதிரி
மல்டிபிள் டெஃபினேஷன் ஆஃப் ஆல் டைமர் பீரியாடிக் எலாப்ஸ்ட். ஓகே, அது 2 டைம் கொடுத்துருக்கீங்கன்னு நினைக்கிறேன். க்ளோஸ் பண்ணுங்க.
இங்க ஒன்று இருக்கு. மேல இங்க இந்த பிகின் டூல இனிஷியலா
இங்க வர இது வந்து ஸ்டார்ட்.
இனிஷியலைசேஷன்.
இது ஸ்டார்ட் தான்.
ஓகே சார்.
ஓகேவா? இது ஆல்
ஒன்லி
அண்டர்ஸ்கோர்.
ஸ்டார்ட்.
ஆமா, ஆல் அண்டர்ஸ்கோர் டைமர் அண்டர்ஸ்கோர் ஸ்டார்ட் அண்டர்ஸ்கோர் ஐடி.
ஓகே சார்.
ஆல் அண்டர்ஸ்கோர் டிஐஎம்
எஸ்
அண்டர்ஸ்கோர்
சார்.
பேஸ்.
எஸ் சார்.
ஆ,
டைம்
நான் ஸ்க்ரீன் ஷேர் பண்றேன். அதை பார்த்து போய் டைப் பண்ணுங்க.
ஓகே சார்.
இது கொடுக்கணும்.
ஸ்டார்ட் ஐடி. ஓகே. டிஐஎம் பேஸ் டைம் பேஸ் டாட் டிஐஎம் பேஸ் டாட் ஐடி. ஐடி. ஓகே. ஸ்டார்ட்.
Okay. Yeah, so others
okay,
can
sir.
leave. Okay, if you don't have any doubts, we can see tomorrow. Okay.
Okay,
Thank you,
thank you,
bye.
sir.
Yeah, thank you. Bye.
Same error.
Same error.
சேம் மல்டி ஃபங்க்ஷன் அதே சேம் எரர் காமிக்குது சார்.
வேற எங்கேயாவது
டைம்
டிக்ளேர்
பீரியட்
பண்ணியிருக்கீங்களான்னு செக் பண்ணி பாருங்க.
ஓகே சார்.
கண்ட்ரோல் F கொடுத்து செக் பண்ணி பாருங்க.
ஓகே சார். கண்ட்ரோல் H all time period
Sir, I am having a doubt.
Yes, Yogesh.
சார் அந்த ஹார்ட்வேர் வாங்கிட்டேன், பட் எனக்கு அந்த ஹார்ட்வேர் டு லேப்டாப் கனெக்ட் பண்ற கேபிள் தான் சார் எங்கேயும் கிடைக்க மாட்டேங்குது. அது என்ன டைப் சார் அது?
அது வந்து USB to mini.
USB to mini. ஓகே.
ஆமா.
ஓகே. தேங்க் யூ சார்.
ஓகே.
சர்ச் பண்ணா ஒன் டைம் தான் சார் வருது. நான் செக் பண்றேன் சார்.
சரி, ஓகே. செக் பண்ணி பாருங்க.
அதான் நாளைக்கு ஒரு இன்டர்வியூ இருக்கு சார், அதான் உங்களுக்கு கால் பண்ணேன்.
அப்படியா? நான் கிளாஸ்ல இருந்தேன், அட்டெண்ட் பண்ண முடியல.
கால். ஓகே ஓகே சார். அது ரைட் அண்ட் டெஸ்ட் மாதிரி சி ப்ரோக்ராமிங் டெஸ்ட் சொல்லியிருந்தாங்க.
ஓகே ஓகே.
அதான் எம்சிக்யூ கொஸ்டின்ஸ். சரி, அதான் நாளைக்கு போய் அட்டெண்ட் பண்ணணும் சார்.
ஓகே ஓகே ஓகே.
சரி ஓகே. ஏதாச்சும் இன்டர்வியூக்கு ஏதாச்சும் கொஸ்டின்ஸ் இருந்தா கேட்கலாம்னு வச்சு.
நான் ஆல்ரெடி
இல்ல
அனுப்பிச்சிருக்கேன்
ஓரளவுக்கு
உங்களுக்கு
அன்னைக்கு. சரி ஓகே சார், நான் ஒரு வாட்டி செக் பண்றேன் சார்.
சரி ஓகே, அதை செக் பண்ணி பாருங்க.
ஓகே. சரி ஓகே சார். ஓகே சார்.
ஆல் தி பெஸ்ட்
சார். தேங்க்யூ சார். ஓகே சார். தேங்க்யூ.